goal while watching this video is to understand really well how to solve two-step equations. So as you're watching, if you have questions, make sure you make note of them so you can get them answered in class. Okay, so quick review. We've talked about expressions which don't have equal signs and equations which do have equal signs. So when we evaluate an expression, we use GERMDAS, PEMDAS, whatever it is that you use to remember the order of operations. So in this problem, 3 times 2 plus 5, first we look for groups. And here's one, but there's nothing I really can do inside the group. There's no operations inside the group. So groups are taken care of. There are no exponents or radicals. There is multiplying or dividing. So we multiply 3 times 2, which is 6. 6 plus 5. There's no more multiplying and dividing, so we can add and subtract from left to right. 6 plus 5 is 11. And we've evaluated our expression. Now, when we solve an equation, so it does have an equal sign, we are not doing math, we are undoing math, because we are trying to get the variable alone. So in this case, we're trying to get x alone. And math has already been done to x. Operations have already been done. We're trying to undo it to get x by itself. So since we're undoing it, or we're reversing what's already been done, we're going to use the order of operations in reverse. So first, we're going to get rid of things that were added and subtracted from the variable. Then we're going to get rid of things that were multiplied and divided from the variable. Lastly, we're going to get rid of things that are in groups with the variable. So let's put that into play. Let's try that a little bit. So first thing I want you to do by example 1 is to write down your order of operations, and then an arrow under it to show that we're going in reverse. And if you read it in reverse, you have sad, Mr. Egg. All right, so sad Mr. Egg is GERMDAS in reverse. But anyway, I just like to write GERMDAS and then write my arrow showing that I'm going through the order of operations in reverse. So I'm going to draw my line. You should too. Remember, we're solving this equation. Our goal is to get that variable all by itself. So I'm going to rewrite this equation so it's a little bit bigger. We have negative 3 times x plus 5 equals 2. Okay? So I'm finding my variable. Here it is. We need to get this guy alone. So order of operations in reverse. First, I want to undo any adding and subtracting that we have. All right? So if I look, I can see that 5 was added to my variable. The opposite of adding 5 is subtracting 5. So I'm going to do that on both sides. 5 minus 5 is 0, so I'm left with negative 3 times x equals 2 minus 5, which is negative 3. Next, all right, next, I am going to check, is there any more adding and subtracting to undo? There's not. So now I'm going to undo any multiplying and dividing. We have negative 3 times x, so we are going to undo that by dividing by negative 3 on both sides. By the way, now we just have a one-step equation left. Right? You're used to doing things that look like this. Okay, so negative 3 divided by negative 3 is positive 1. We're left with 1 positive x equals negative 3 divided by negative 3, which is positive 1. So x is the same as 1. I should always check my answer, so down here I'm going to rewrite my original equation, negative 3 times x. We think x is 1. Plus 5 equals 2. And I want to make sure, is that true? Did I get the right answer? Negative 3 times 1 is negative 3. Negative 3 plus 5 is 2. So we solved that one correctly. If you need more time to write this down, pause. I'm going to go on to the next one. Okay, we did one like this yesterday. And there are a couple ways we can do two-step equations like this. A couple ways we can solve them. So yesterday what we did is we said, oh, we have 3 x minus 4s. So we did x minus 4, x minus 4, x minus 4 with our algebra tiles, and we said altogether that's 3 x's minus 12. And that equals 9. So if you do it that way, you're distributing first. You're saying, oh, this is 3 times everything in the group, 3 x's and 3 4's. Okay. I'm going to write my order of operations and draw my arrow to show that since we're solving, we're going through the order of operations in reverse. So in my equation, all right, undo things that were added and subtracted to the variable first. So first they subtracted 12. If they subtract 12, I add 12. Right? Negative 12 plus 12 is 0. So I'm left with 3x equals 9 plus 12, which is 21. All right? There's nothing else on the side with the variable being added or subtracted. So we don't have to worry about adding and subtracting anymore, undoing it. We do, however, have to undo the multiplication and division next. So they took 3 times x. I am going to divide by 3 on both sides. 3 divided by 3 is 1. So I have 1 positive x equals 21 divided by 3, which is 7. Final step you need to do is check your answer. So we are going to take 7 and plug it back into our original equation for x. So I'm rewriting my original equation, which was 3 times x minus 4 equals 9. Instead of writing x, I'm going to write what I think x is, which is 7. And I'm going to check to make sure that really works. So 7 minus 4 is 3. Is 3 times 3 really 9? It is, so we've got our answer correct. Pause if you need more time to get that written down. Next example. Looks harder, but it's the exact same process. So it says solve, so I know I'm going to use my order of operations in reverse. Because I'm undoing the operations that were done to the variable. Okay? If this equation doesn't make a lot of sense, all right, you can write it a different way. So you could say x is being divided by 8. X is being divided by 8, and they're subtracting 1/2 off of that. And that equals negative 7/2. So order of operations in reverse, we're undoing what was done to the variable. First, we're getting rid of things that were added or subtracted from our variable. So they subtracted 1/2. The opposite of that would be add 1/2 on both sides. All right, negative 1/2 and positive 1/2 make 0. So we're left with x divided by 8 plus 0, which is just x divided by 8. On the other side, we have negative 7 plus 1 over 2. Negative 7 plus 1 is negative 6. Negative 6 over 2 can be simplified to negative 3, because remember, this means negative 6 divided by 2 as well. So negative 6 divided by 2 equals negative 3. All of a sudden, our equation does not look so ugly, right? It's very manageable. It's just a one-step equation now, and the fractions are gone. Thank goodness. So our variable is still not alone. They divided it by 8, so we're going to multiply it by 8. All right, so we have 1 positive x equals negative 3 times 8, which is negative 24. Again, have to do the all-important check. So back in my original equation, we're going to do this in a different color. Original equation is x divided by 8. We think x is negative 24. So negative 24 divided by 8 minus 1/2. I'm still getting all this from up here. Should equal negative 7/2. All right. So negative 24 divided by 8 is negative 3. Negative 3 minus 1/2. Is it really negative 7/2? Do the math. It is. So our answer of negative 24 must be correct. All right, last one. Right? From the title, you can kind of get a hint of what we're doing here. Combining like terms before solving. So sometimes two-step equations, your first step is to combine something on one of the sides. You can condense it before you start to solve it. So over here, 3y minus 8y equals 25. Think about that. If I have 3 positive y's, remember another way to write this is 3y plus negative 8y equals 25. Right? So that's saying I have 3 positive y's and I have 8 negative y's. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay. A positive y and a negative y cancel out. Positive y and negative y cancel out. So we're left with 6 negative y's. So all we've done is combine these two things. All right, instead of saying I have 3 yams minus 8 yams, I'm saying I have negative 6 yams, or whatever y is. All right, so I've combined my variable, except just kidding. I combined them wrong. Just wanted to see if you knew. Nobody said anything. All right, so 3y and negative 8y, we just cancel out one more of these. So I actually have 5 negative y. All right, 3y minus 8y is negative 5y. Then we're down to a one-step equation. All right, to get y alone, the only thing with y is a negative 5 that was multiplied to it. So they multiplied negative 5. We divide negative 5 on both sides, of course. So we're left with y equals 25 divided by negative 5, which is negative 5. If we would go check that answer, it will look like this. 3 times y. So 3 times negative 5 minus 8 times y should equal 25. So let's check that. 3 times negative 5 is negative 15. Minus 8 times negative 5 is negative 40. Negative 15 plus 40, all right? Because subtraction is the same as adding, the opposite. Negative 15 plus 40, is it really 25? It is, all right? So we solved our equation correctly. We have the correct value